All right, ladies and gentlemen, we are now starting our part 3 of chemical equations, the why and how. Part 3 is about balancing equations, so hopefully you have your note sheet there and are ready to go. A little bit of a review to start out with, though. This isn't on your note sheet. Just reviewing how to count atoms as we were doing last week. So let's take a look here. We have 3CH4. 3CH4. So we've got carbon, we have hydrogen. So then the question becomes, how many of each of those do we have? Well, ladies and gentlemen, let's go over here. So we have 3 molecules of CH4. All right, so we have 3 of this entire thing right here, this entire molecule, CH4. So this 3 is going to get distributed to everything in this molecule because there's 3 of everything here, which means that we have 3 carbons. We have 4 hydrogens right here, but we have it 3 times. So 4 hydrogens 3 times gives us a total of 12 hydrogens. Don't forget to multiply when we are working with counting atoms, ladies and gents. There were a handful of people who in your practice with counting atoms did some addition instead of some multiplication. Go back and take a look at that assignment. Look at the feedback that I may have put in there just as a reminder to try and help you. All right, so we're going to move on to how to balance chemical equations. So the whole idea is that we know the law of conservation of mass tells us that during a chemical reaction, matter cannot be created or destroyed. And if that's the case, then all of the atoms that we start with have to still be around at the end. They have perhaps rearranged themselves into different combinations of molecules, but all of the atoms are still there. And so sometimes when we first write down what substances we started with and what substances we end with in a chemical equation, we might not have the amounts correct. So we get the amounts correct by balancing the equation. Let's take a look at an equation that is balanced. So here is the same equation from the experiment from the Goofy video that you watched last week with the guy who put the hydrochloric acid and the zinc together. There's a reaction. Eventually he caught the balloon on fire and blew it up. So here's the equation that goes with that. In this equation, it is balanced. Okay, we have reactants of HCl, hydrogen chloride, and then zinc. Our products are H2, hydrogen gas, and zinc chloride, ZnCl2. There are equal numbers and kinds of atoms in both the reactants as there are in the products. So if we were to take a look over here, we have HCl and we have 2, so 2H and 2Cl right there. And then we have zinc. Over here we have 2H and we have 1 zinc and we have 2Cl. So, ladies and gentlemen, for hydrogen, we have 2 on one side, 2 on the other side. For chlorine, we have 2 on the reactant side, we have 2 on the product side. And for zinc, we have 2 on the reactant side and 2, no, excuse me, I am so sorry. We do not have 2 on each side there. We have 1 on each side. We have 1 and we have 1. Here's our 1, here's our 1. Because remember, the subscript only goes with the chlorine because it only goes with the element that comes immediately before it, not with the entire molecule. If something goes with the entire molecule, we either have to have a coefficient in front or we have to have parentheses. All right, so ladies and gentlemen, let's take a look at chemical equations. In order for a chemical equation to be well written, there are a few things that need to be true about it. So the first one is that it has to represent a real situation. Okay, you can't just make up what happens in a chemical reaction. It has to be something that could actually happen. It has to be elements that would actually react with each other, and it has to be a product that would actually form from those elements reacting with each other. It also needs to contain the correct formulas for those reactants and products. So you can't just make up random letters and things like that and random combinations of letters. You have to have the correct formulas. And then it has to abide by the law of conservation of mass, which means that atoms are never created or destroyed during chemical reactions, which means the amount of each element has to be the same on each side of the chemical equation, because you can't create something and you can't destroy something. So it has to be the same on both sides. All right, let's take a little bit of a look at balancing chemical equations. And the fact is that there are some rules that you have to follow when we balance chemical equations. So there are some guidelines that you have to go with. So here are our guidelines. Let's start with the first one. You can only add a coefficient in front of a chemical formula. Okay, that is the only thing that you are allowed to change. Okay, you are a junior high introduction to chemistry student. You will always be given, in this situation, the reactants and the products. You may not always be given the correct amounts. All right, and that's where balancing comes in. But you will always be given the correct formulas for both the reactants and the products. So you're not going to change any formulas. Formulas are made up of the element symbols and the subscripts. That means that the only thing that you can change, if you can't change the formula, are the coefficients, or the big numbers that are in front of the molecules that tell us how many molecules of that particular substance actually took place or were actually a part of that chemical reaction. Okay, so the only thing that you can actually change are the things like the coefficients, these large numbers in front. You cannot change any subscripts. You cannot add any subscripts. So anytime you see one of these little numbers down here, you may not touch that. You may not add any of those. Those are a part of the formula, and you cannot change the formula. You may not place a coefficient in the middle of a chemical formula. Okay? That does not work. Coefficients have to be at the beginning of a formula, because coefficients tell us how many molecules there are of a particular substance. So if you tried to add a coefficient in the middle of a molecule, then you're trying to tell us that you're adding only part of a molecule or in there, and you just can't do that. We already know the substance that we're working with. We have to keep that formula. And ladies and gentlemen, you need to end up with the same number and same kinds of atoms on both sides of the equation when you are finished. So make sure that you count the atoms on both sides when you are done to make sure. So if we look here, this arrow right here is always kind of the dividing line in our equation. It's a little bit like an equal sign, but we said last week that it's not truly an equal sign. It means to like produce or yield. But this is like our middle point. So we're looking to see, okay, does this side balance with this side? Okay, here's our middle. So over here we have 2AB 2. So this 2 goes with both the A and the B2. Over here we have A2 and we have 4B. So here I have 2 A's. Here I have 2 A's. Here I have B2, and I have it 2 times, so I have 4 B's, and over here I have 4 B's. So I have 2 A's on each side, 4 B's on each side. This is a balanced equation. All right, so let's take a look at trying to actually balance an equation ourselves. So we could take and write an equation in words. Hydrogen gas plus chlorine gas, or hydrogen gas reacting with chlorine gas, yields hydrogen chloride. That's all well and good, but it's a whole lot shorter to write it in its chemical equation form with formulas. So H2 reacts with Cl2, and this yields or produces HCl. However, this equation is not balanced. On this side of the equation, we have 2 hydrogen, but on this side, we only have 1. On this side of the equation, we have 2 chlorines, but on this side, we only have 1. That would imply that matter has been destroyed. Can't happen. So apparently, when the actual reaction happened, this was not the proportions that it happened in. So we need to find out, how did it happen? So we're going to begin by counting the atoms on both sides of the arrow. Now, ladies and gentlemen, in your notes, I would strongly urge you, you have on the back side or on the second page of your notes, you have this equation written there. I'm going to suggest that as things kind of pop up on the screen here, that you add those things to it, and I'll kind of point that out as we go. So we're going to begin by counting atoms on both sides of the arrow. Remember, the arrow is kind of our dividing point in the equation. Divides one side from the other, the reactants from the products. And you also need to remember that the number and kinds of atoms in the reactants has to be the same as in the products. Okay, so I would strongly suggest, in fact, I'm pretty much going to require you to draw a line underneath the arrow that helps you to divide this equation in half. Now, you don't have to scribble the line like I just did, but I was trying to highlight it a little bit there for you. So draw a line under the arrow. Then on each side, write down what elements you have. So you have hydrogen and you have chlorine over on this side. We know they're going to give us the correct formulas, which means we should have the exact same elements on the other side. Please write them in the same order on each side. Now, in this case, they're listed in the same order. Hydrogen is first on this side, hydrogen is first on this side. Chlorine is second, chlorine is second. That's not always the case. But it is much easier to compare how many hydrogen are on this side to how many hydrogen on this side if they are all lined up. Okay, so I'm just going to kind of erase this line there. All right, so ladies and gentlemen, we can see that on this side of the equation over here, the reactants, remember this is the reactant side, we have 2 hydrogen and we have 2 chlorine. They each have a subscript of 2. There's no coefficients, so that's how many we have of each. However, on the product side, remember that's the right side of the equation, we have 1 hydrogen and 1 chlorine. There's no coefficient out front, and so that's all we have. That is clearly not balanced. All right, so as I mentioned before, it would seem as though some hydrogen and some chlorine was somehow lost or disappeared in this reaction. That goes against the law of conservation of mass, and so we know that it must not be true. So we need to balance the equation by adding coefficients to balance this out. So if we have 2 hydrogen on this side and 2 chlorine on this side, we know that we're going to need 2 hydrogen over here on the product side and 2 hydrogen on the, or 2 chlorine on the product side, because we can't destroy anything, so all we can do is increase the numbers. We can't decrease them. So we're going to put a coefficient of 2 in front of the molecule HCl. When we do this, now all of a sudden we have 2 hydrogen, because this 2 goes to the hydrogen, This 2 also goes to the chlorine because it goes to the entire molecule. We now have 2 chlorine. And so, ladies and gentlemen, let's take a look. 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine. This is now a balanced equation. So the correct way to actually write this balanced equation would be to write H2 reacts with, sorry, that's not a very good plus sign there. My computer screen is bouncing. Reacts with Cl2, and that yields or produces 2HCl. Okay, I'm going to try and fix that plus sign because it's kind of bothering me. So we'll go back over here, see if we can't improve that. Maybe we can, maybe we can't. There we go. I like that a little better. Okay. So now we have a balanced equation that satisfies the law of conservation of mass. Let's take a look at another equation. This one is Al reacts with O2, so aluminum reacts with oxygen gas, and it yields Al2O3. All right, so they have already drawn the line in between, which you are always going to draw to split your two sides of the equation. Over here we have 1 aluminum, so they've written 1 aluminum. On this side we have 2 oxygen, and remember this is the reactant side and this is the product side. So we have 1 aluminum, and over here we have 2 oxygen because we have O2. Okay. On the product side we have 2 aluminum. We have Al2 and we have O3, or 3 oxygens. This is not balanced. Okay. The aluminums aren't balanced, the oxygens aren't balanced. We need to do some work. So, well, you know, we could try adding a 2 in front of the aluminum because we know we need at least 2 aluminums, right? So we could try adding a 2 in front of the aluminum and see what happens there. If we do that, that changes our aluminum to 2. It was 1, but now it's 2 because we think we might need 2 molecules of aluminum. Our oxygen didn't change, okay? That 2 only goes with the aluminum. There is a plus sign in between those two things, which means that the O2 is a completely different molecule. So that 2 out in front, that coefficient of 2, only goes to the aluminum in this case. It only goes to the one substance. It doesn't go to all kinds of substances. We still have O2. On the product side, we still have exactly what we had before because we didn't change anything on the product side. So now our aluminums are balanced. However, our oxygens still are not. We've got 2 oxygens, 3 oxygens. It's not balanced. It didn't work. That's okay. Doesn't mean you give up. Just means we try some other things. So let's stick with what we've got. Let's stick with that 2 in front of aluminum, and because the aluminum is balanced. So let's see if we can do some messing around with the oxygen to get that balanced. So we've got 2 oxygen over here, we've got 3 over here, so we know we're going to need a minimum of 3. But now the question becomes, okay, we can add a coefficient out in front of oxygen, but is there anything that when we multiply it by 2 that will equal 3? 2 times something, does it equal 3? No, it doesn't. The best thing to do when you're working with odd numbers is to go ahead and try to figure out the least common multiple between the 2 numbers you're working with. You're working with a 3, you're working with a 2. What is the least common multiple between them? Well, the multiples of 2 are 2, 4, 6, 8, 10, so on and so forth. The multiples of 3 are 3, 6, 9, 12. Well, they both have 6 in common. So how do we get from 2 to 6? Well, we multiply by 3. Okay, well that's great. So 3 times 2, 3 O2s gives us 6. Awesome. Okay. Well, we've got to get the product side to 6 oxygens then as well. We can't put a coefficient somewhere in the middle of the Al2O3. It has to be out in front. So how do we get from O3 to having 6 oxygens? Well, we multiply by 2. But remember, this 2 is going to have to go with the aluminum and with the oxygen. Right now, let's deal with the oxygen. So 2 O3s gives us 6 oxygens. We have O3 2 times. Now, our oxygens are balanced, but unfortunately, by adding that 2 out there, we actually changed our aluminum as well. We changed our aluminum to how many? Yeah, we changed it to 4 because now we have Al2 and we have that 2 times. All right. Now the question is, we've got the oxygens balanced, but now our aluminums are out of balance again. Is there anything we can do to fix that? Yeah, I think there is. All right, so they're showing the same thing. They just added a 3 and a 2 in there like I did. But this changes the numbers below. And so this is what I just showed you a moment ago. Our oxygens are balanced. Our aluminums are not. Okay, so what can we do to fix that? Well, if we take away the 2 in front of the Al on the reactant side, again, reactants, products, and change that coefficient instead of a 2 to a 4, now with a 4 out here instead, we have 4 Al on this side. We have 2 Al2s on this side, which gives us 4 aluminums over here. We have 3 O2s here, and we have 2 O3s here. It gives us 6 and 6. Everything is now balanced. All right, so ladies and gentlemen, we're going to do some more practice with this tomorrow. All right, so if you're feeling a little confused, that's okay. Please ask me questions. I'm around. I'm here. I'm more than willing to answer your questions. We will go over some of this again tomorrow. You will be practicing doing some of your own balanced equations tomorrow. All right, have a great day, guys.